Factor the following expressions. We start with part A, which says 4x cubed minus 9x. This expression has two terms. One term is 4x cubed. The other term is minus 9x. In these two terms, 4 and 9 have only 1 in common as a common factor. However, x cubed and x have an x in common. Therefore, I will factor this common factor from both expressions. From the first term and from the second term, both, from each I will factor an x. If I factor an x from the first term, I will be left with 4x squared. And if I factor an x from the second term, I will be left with a minus 9. By a close look at the resulting expression, I realized that I can rewrite this part of the expression as the difference of two complete squares. Instead of 4x squared, I can write 2x squared. Because 2x squared, once you open it, you will get 4x squared minus, and instead of 9, I can write 3 squared. Now, using the identity a squared minus b squared equal to a minus b times a plus b, I can see that my expression would be equal to x times. Now, in our problem, you can think of 2x as a, and you can think of 3 as b. If you do that, you can write the expression as 2x minus 3, which is a minus b times 2x plus 3, which is a plus b. Now, all these three factors, x, 2x minus 3, and 2x plus 3, are prime factors, and they cannot be factored any further. Therefore, we leave the answer as it is right now. Part B of the question asks us to factor x squared minus 5x plus 4. This is a quadratic expression, and the terms, which are 3, one is x squared, the other one is minus 5x, and the other one is plus 4, are arranged in the descending orders of powers of x. So you first have x squared, then you have x, and then you have x to the power of 0. So this would be x to the power of 1. You have x to the power of 0, which you can already write as 1. So this guy would be equal to x squared minus 5x plus 4. Let's call this the standard form of the quadratic expression. To factor this, you will note that the coefficient of the leading term, which is x squared, is 1. I'm going to consider this 1 and 4 together and minus 5 separately in the following way. I should look for two numbers. I'll show them by a circle and a square. I should look for two numbers that if I add them, I get minus 5, and if I multiply these numbers, I would get 1, which is the coefficient of x squared, times 4, which is the constant term. By a close look and a bit of thinking, I can guess that the two numbers would be -1 and -4. In fact, -1 plus -4 is equal to -5, and -1 times -4 is equal to 4, which is the same as 1 times 4. Therefore, I have found the two numbers I was looking for. In case we could not come up with these numbers by guessing, there is a procedure which would work for small numbers, small coefficients, such as in our problem, which when we have 1, -5, 4, you would first look at the product, 4 times 1. This is 4. 4 can be written as 1 times 4 minus 1 times -4 can be written as -2 times -2 can be written as 2 times 2, and I cannot think of any other factoring. So the answer would be one of these possibilities. 1 times 4 would not be the answer to our problem because 1 plus 4 is not equal to -5. So the first condition would fail. -1 minus 4, this one would satisfy our condition as I explained. -2 and -2, this case, if you add them you would get -4, which again fails the first condition. And 2 times 2, that would also, if we add the two numbers, we would get 2 plus 2, which ends up 4, which again fails the first condition. Therefore the only possibility is -1 and -4. Once we found these two numbers, we can go back to our original expression, and instead of -5x, use the two numbers that we have found, write -4x minus x. It doesn't matter if you write -x minus 4x. At the end, the final answer would not be different. And then we also had a plus 4. So to summarize, instead of -5x, I wrote -4x minus x. Now from the first two terms, I can factor an x. Then from the first term, I'll be left with an x, and from the second term, I'll be left with a 4. If I now consider the last two terms, I can factor a -1. From the first term, I'll be left with x, and from the second term of these two terms, I'll get a -4. In order to understand why there has to be a minus sign here, you can go backwards. You can multiply this negative sign, which is in fact -1, into the bracket, and you must get -x plus 4. That is why you should have a minus sign here. Let me rewrite the expression one more time. X times x minus 4 minus x minus 4. Now here we have two terms. This is one term and this is the other term. These two terms share a factor, and that is x minus 4. I will take x minus 4 out of both these terms. From the first term, if you move x minus 4, you will be left with an x only. And from the second term, if you move x minus 4, you will be left with a -1 only. And this would be the answer to our problem, because both of these factors now are prime factors and cannot be factored anymore. We can check our answer as well anytime we're not sure of our answer. So in our case, if I wanted to check, I would go backwards. Let's open x minus 4 times x minus 1, and that's how I would open this product. I'll have x squared minus x minus 4x plus 4, that is x squared minus 5x plus 4, which is the original expression we started with. Now let's have a look at part C of this question. They ask us to factor 3x squared minus 7x minus 6. Again, this is a quadratic expression, and the terms are arranged in the descending order of the powers of x. You first have x squared, then x to the power of 1, and then x to the power of 0. Once the quadratic expression is in the standard form, as it is right now, in order to factor the expression, you would need to find two numbers that if you add them, you would get minus 7, which is the coefficient of x, and if you multiply them, you would get 3, which is the coefficient of the leading term, times minus 6, which is the constant term. Or in other words, if you multiply the two numbers, you would get minus 18. We need to find two numbers that if we add, we get minus 7, and if we multiply them, we get minus 18. Suppose we can't guess the answer. Let's see whether, following the procedure I outlined in the previous part, we can find the numbers. We start with minus 18. I can write minus 18 as 2 times minus 9 minus 2 times 9, 1 times minus 18 minus 1 times 18, 3 times 6, let's say minus 6, and minus 3 times 6, and there is no other factoring I can think of. Now let's see, these are all possibilities for two numbers to multiply into minus 18. Let's see which one of these numbers would satisfy the first condition, which is this one. The sum of the two numbers should be minus 7. The sum of 2 and minus 9 is minus 7, so I already have my answer, 2 and minus 9. But let's check the other ones. They must all fail the first condition. Minus 2 plus 9, that's a 7. 1 minus 18, that's minus 17. Minus 1 plus 18, that is 17. 3 plus minus 6, that's minus 3. It is not minus 7. Minus 3 plus 6, that's a 3, and it is not minus 7. So the two numbers are 2 and minus 9. I can write minus 7 is 2 plus minus 9. Let's take this and sub it into our original expression. We would have 3x squared plus 2x minus 9x minus 6. Again, it really doesn't matter if you write minus 9x first or you write 2x first. It could somehow simplify or complicate the solution, but the final answer would be the same in either case. Now we have four terms: 3x squared plus 2x minus 9x and minus 6. From the first two terms I can factor an x, in which case I will be left with 3x plus 2. From the last two terms I can factor a 3, in which case I will be left with 3x plus 2 again. Now I have two terms, x times 3x plus 2 and minus 3 times 3x plus 2. These two terms share a factor, which is 3x plus 2. Once I factor it, I will be left with x minus 3. We can of course check our answer by going backwards. So let's see whether 3x plus 2 times x minus 3, once it's opened, it would lead us back to the original expression. Okay, 3x times x, 3x times minus 3, 2 times x, 2 times minus 3. That would be 3x squared minus 9x plus 2x minus 6, and that is 3x squared minus 7x minus 6, which is our original expression.